all the way back and do just a little bit of fractions first. Because the rules for fractions are going to be really important. Because this word rational has the word ratio in it. And so rational equations are equations that have x's in the denominator. So just to like give you a glance at what we're talking about stuff like this, where we've got all kinds of x's in fractions. If you don't know how to add, subtract, multiply, and divide fractions whenever you're just dealing with numbers, you're going to have a real hard time on this stuff. Okay, so I will admit that myself was probably in at least Algebra 1, but maybe even really Algebra 2, before somehow I really realized that the rules for fractions were really simple. Because I, like most children, I think, you learn how to do them in 5th and 6th grade, and you guys were probably even good at them in 5th and 6th grade whenever you were doing fractions. But then they handed you a calculator that would do fractions, and you're like, forget that. I don't ever need to learn how to add or subtract a fraction ever again. And so we forget a lot of those rules to do this. So when we got to add or subtract, what have we got to do first? Common denominators. You must have common denominators to add and subtract. You cannot say this is 8 over 8. Right? Just add top, add bottom. You can't do that here. So you got to get common denominators. What would it be for this one? 15. So I've multiplied this first fraction by 5. Well, that's not let me write today. Possessed. It won't let me write the 5 right there. It won't. I'm trying to multiply by 5. Oh, there's like 7 5s on top of each other. Okay. Multiply by 5 on top and bottom here. I think my computer is trying to cause me to close my eyes. Okay. So I got 10 over 15 plus 20. I'm sorry, that's not 5. My computer was messing with me so much I'm going to use that as my excuse for missing that right there. I'm multiplying by 3 on top and bottom here, which is going to give me 12 over 15. So whenever we add fractions, what do? Add the top, keep the bottom. So 22 over 15. If you're ever unsure about what to do with adding fractions, think of the most simple fraction you know how to add, 1/2 plus 1/2. And if I added the top and added the bottom, I'd get 2/4, which is 1/2, which was clearly wrong, right? So I always think back to that right there. Of course, you'd have to do 1/2 plus 1/2 would be 2/2, which is 1. So make sure that you understand. Subtracting is the same thing. You must have common denominators. So you might even want to make yourself a note. You must have common denominators to add or subtract fractions. So you must have common denominators. That is true if you're dealing with numbers. It's also true if you're dealing with some expression that has an x. Okay? So if you have a denominator of 3x, the other fraction has to have a denominator of 3x before you can add them together. What about multiplying fractions? What if I'm doing 4/5 times 20/3? Okay, multiply top, multiply bottom, multiply straight across. So I can do it this way. I can do 80 over 15. But that will reduce. So 80 divided by 5 is going to be 16, I believe. And 15 divided by 5 is 3. So it would be 16/3. Does anybody know the trick I could have used so I didn't have to reduce there at the end? Not cross multiply, but it is sort of cross. Or cross, like getting the same denominator?
Like, 5 and 20, so 5 goes in both, so 5 or 4 over 5.
Yes. So whenever we reduce, we can't reduce 4 over 5 and we can't reduce 20 over 3. But we could look here, 5 and 20. You can reduce anything in the top with anything in the bottom when you're multiplying. So, like Matthew said, 5 goes into both of those. So 20 divided by 5 would be 4, and 5 divided by 5 would just be 1. So you can reduce both 4, you multiply, and then say 4 times 4 is 16, 1 times 3 is 3. So I like to do that because usually you're doing with smaller numbers if you do that, instead of 80 over 15. Sometimes you get really big numbers that are just hard to deal with, or you may not realize they reduce if you do that. So multiplying straight across, I think multiplying is easier than adding and subtracting. You do not have to have common denominators to multiply or divide. And then we've done some dividing fractions. What do we do for dividing fractions? Flip the second and multiply. So dividing fractions. Easy as pie. Flip the second and multiply. Alright, so if I had something like 22 over 15 divided by 8 over 3. Make that 3 over 8, actually. Just because I want one that will reduce it. So, dividing fractions easy as pie, flip second, multiply. So, 22 over 15, if it's written like this, the bottom fraction is always your second, so 8. Oh, shoot. Change that back to 3 over 8. Or, no, 8 over 3. I wanted one that would reduce. Alright, so, 22 over 15 times 3 over 8. This one's definitely one you want to reduce before you multiply it together. So whenever you do this, 5 will go into 15, and 3 will go into 15 and 3. So you could make this 5, and you could make this 1. And then 2 goes into 22 and 8. So we could make this 11, and we could make this 4. So 11 times 1 is 11. 5 times 4 is 20. It is much easier to reduce before you multiply rather than after, especially on that one. All right, questions? All right, so let's look at some stuff that actually applies to our class here. So for example 1, we've got 45 x to the third over 5x. Put this up here so we're looking at one at a time. So here, I can treat my expressions, my coefficients separately from my x's here. And so 45 and 5, could I reduce those? Yeah, I could divide both of them by 5. Divide by 5. So that would give me a 9 on top, just a 1 on bottom. You don't necessarily have to put the 1 there. Then I've got 3 x's on top. Oh, sorry. And 1 of them on bottom. What is that going to do? Good. So I'm going to have an x squared left on top. Do I need this 1 down here? No, it makes me look like I don't know what I'm doing if I leave that 1 there. So I'm just going to make it 9x squared. So your coefficients, you're going to divide, or in this case divide, but sometimes you just reduce them. The exponents here, this was a 3, this is a 1. I can basically just subtract my exponents, right? And then wherever I have the most x's, that's where my answer is going to end up. Let's try this one. Alright, so I got 28x to the third, 56x to the seventh. Is there anything that will go into 28 and 56? Oh, 28 does? Oh, it is, isn't it? I was expecting 7. 7 goes into both of them, but I guess you would probably have to reduce after that as well. So we can divide both of those by 28. But for some reason it won't let me write. So we just get a 1 over 2. And then with my x's, I'm going to subtract those exponents. It gives me 4. Where do I put those 4 x's? Bottom, because I've got more x's in the bottom. You do need this 1 here this time because it's in the numerator. So it's 1 over 2x to the 4th. Now if you're like me and thinking 7 there, then you would have gotten 4 over 8, but then of course 4 over 8 would have reduced to 1/2, so you could have kept going there. Okay, let's look at what happens with example 3. So for example 3, we got x plus 2 over x squared plus 5x plus 6. Okay, so do not do what I'm about to do because it is very wrong. So we could reduce things here and cancel them because everything was multiplied. There. If I have something like 1 plus 2 over 3 plus 2, right? What do I get when I do 1 plus 2 over 3 plus 2? We get 3 fifths. We're all okay with that, right? Just add the top, add the bottom. Alright, so here's what some students want to start doing when I start throwing x's in there. They want to say, oh look, there is a 2 in the top and bottom. I'm going to cancel it. And so if I cancel it, I get 1/3. Is that right? That's terribly wrong. Okay? Now, it's more obvious that it is incorrect here, right? Most of you would not do that if I gave you 1 plus 2 over 3 plus 2. So most of you would not do that. But when you got x's, it becomes less obvious. So, I'm going to pause this here for a minute. Can't do anything here. Except, what could we do to that bottom part to make it look different? We could factor it. So, x plus 2 over, this would be x plus 2, x plus 3. Okay, so now I've got multiplication here between my x plus 2 and my x plus 3, right? The stuff is being multiplied together. I could even, like, when I cancel this, there's not going to be anything there, but I could put like a times 1 there, right? It would be multiplied by 1. So I can cancel these out now, and this reduces to 1 over x plus 3. Oh, there's one other thing I should have done. Except, this does not this expression does not equal 1 over x plus 3 at every single value. There is one place where you're going to have an issue with it. Okay? So, we have been talking about domain a lot. So for domain, we cannot have zeros in a denominator of a fraction, correct? So, obviously, what number can I not have in the bottom of this fraction? Negative 3. Because 0 would be okay, because 0 plus 3 would give you 3. Right, at the end we can't have 0. But we can't have negative 3. So x cannot equal negative 3 here. Okay? So whenever I'm looking at this problem, this is what we'll call an excluded value. You cannot have negative 3. You cannot plug negative 3 into this expression. But there is another one. So for this, it would be fine to put in negative 2 for the simplified version. But would it work if I put negative 2 in this original equation? If I tried to put negative 2 there, the top, well, it's okay for the top to be 0, but the bottom's going to be 0 too. If I put negative 2 squared plus 5 times negative 2, which is not as easy to see right away, but you have 4 minus 10 plus 6, you're getting 0 over 0. So you got zeros in the denominator. So for this, x cannot equal negative 2, so that is also an excluded value. I really should, I usually do that before I actually cancel things, but I forgot to do it this time. So this expression right here matches this expression right here at every point on the graph except x cannot equal at negative 3 and negative 2 because they're undefined at those points. Okay. So let's look at another problem. This one's bigger. All right, so again, all right, so again, if I gave this to some of you on down the road from here, hopefully you wouldn't do it right now, you might start wanting to do this, marking out those x squared. They just cancel each other out. Maybe mark out that x, mark out this x. Can we do that? No, because we got plus and minus signs between everything. So let's not do that. So let's just factor everything. It's generally a good practice to factor everything. So this numerator here factors into x plus 1, x plus 1. The denominator is x plus 1, x plus 3. And then I've got x plus 4 over here, and then negative x minus 1. Alright, so before we actually cancel anything, let's think about our excluded values, okay? Anything that would give me a 0 in any part of the denominator is going to be an excluded value. You're going to have on your assignment, like, some problems that just ask you to find excluded values. They don't even want you to solve. They just want you to tell them what the excluded values are. So x plus 1 is in the denominator, so it cannot equal 0. So that means, of course, that x cannot equal negative 1. You don't have to show the work from that. You can just list them if you want. But I just want to try to be very clear about what we're doing here. X plus 3 cannot equal 0. So that's going to be x cannot equal negative 3. So we got an excluded value here, an excluded value here. We're also going to have negative x minus 1 cannot equal 0. So we move that 1 over, negative x cannot equal 1, x cannot equal -1. That actually ends up being the same thing as we had up here, so we don't have to list it twice. So these are our excluded values. So these need to be listed whenever you're simplifying. Okay, do we care about the numerators for excluded values? It's okay for us to have zeros in the top, just not in the bottom. So now that we have this looking like this, I can cancel my x plus 1s. Is there anything else that might cancel? Obviously, x plus 3 and x plus 4 do not cancel. X plus 1 and negative x minus 1 look really close to each other. I almost want to cancel it. But I can't as it is right now. How could I change this right here so that I could cancel? Okay, I could pull the negative out front, which is similar to multiplying by a negative, but I can't just multiply by a negative. Actually, I could multiply by a negative as long as I multiply the top of the fraction by a negative as well. So you could do that and you'll get the right answer. Or we could think about this. We could factor out the -1. So we could write it like this, negative 1 times x plus 1. Right, factor that greatest common factor out. Now, this is multiplied still. Now I can cancel the x plus 1s. So sometimes it might not be very obvious, or they might look a little bit different. Sometimes you can change those up a little bit. So I end up with, on the top, I just have an x plus 4. And on the bottom, I have -1 times x plus 3. You may see that -1 written like, they probably won't write the 1. Let me just put a negative there. You might see it written like this. You might see it where they've distributed it. I think most likely, if it's multiple choice, you're going to see that it looks like this. They put that negative out front, which is okay, because like if I want to write -1/3, I can put the negative in the top, I can put the negative out front, or I could put the negative in the bottom, and those are all equal to each other. So that negative right there, since it goes with everything, could be put out front. For me, I don't really care how you leave your answer as far as whether it looks like this or this. We will probably, this unit is probably going to have paper tests on this instead of a Canvas test, because for these I don't like to give multiple choice on these, because if I give you multiple choice, all you gotta do is just plug back in the number and you don't really have to know how to do it. And I don't like giving number answers because the problems are kind of long and there's not going to be as many of them. Like I might not put the 15 problems on the test. And if I give type in the answer problems, then you are going to miss 8 points for one problem where all you might have done is miss the negative. So it'll probably be a paper test for this one. Okay. Questions on that one? Alright, so for example 5, I'm dividing. So I got x plus 5 over x squared minus 3x minus 4, and then x squared minus 2x plus 1 over x minus 4. We should have competition between your class and the calculus class on bad canceling. I should keep track of how many times I catch them doing some bad canceling and how many times I catch you guys doing bad canceling. And there should be a reward for the winning class. We might start Monday. You guys don't know how to, I haven't taught you much yet about it, but Monday we might start. I'm going to let them know about it. Because we're doing some fraction stuff now, too, with them. Okay, so, dividing fractions, easy as pie, flip the second and multiply. I'm going to go ahead and factor as I do this. So, the denominator here is going to be x minus 4, x plus 1. Right, so I'm just taking that and factoring it here. And then I've got to flip the second, so x minus 4 is going to be on top here. And I'm going to factor the x squared minus 2x plus 1. So that is going to be x minus 1, x minus 1. So, we need to look at the denominators for our excluded values, just because those need to be listed for all of these. So, I'm going to say that x cannot equal 4, because this cannot equal 0. 4 would make that 0. X cannot equal negative 1. That comes from this one right here. X cannot equal 1. That comes from right here. I'm just setting each one of those equal to 0 and solving that in my head, right? I think you guys are pretty good with that. And then, one more thing about this. You can see I had this circled and I didn't erase it. The denominators here cannot be 0, but also the denominators of those original fractions cannot be 0. So that means this part cannot be 0, which was this part, so I don't have to worry about it. I've already taken care of it. But this x minus 4 cannot equal 0. And it ended up on the top up here, right? So you also need to consider it. Now we're okay here because that factor was already in the denominator, so we're covered that the x equals 4, or x cannot equal 4. But sometimes it's not. Sometimes it might be like an x minus 7 there, and you need to also say x cannot equal 7 if that's the case. So look at the denominators of your original problem, and then also look at the denominators once you have flipped the fraction. Okay? Alright. So, we can cancel an x minus 4 here, and that is all. So, in the numerator, we're just going to have x plus 5. In the denominator, we're going to have x plus 1. And you're probably going to see it written like this. When you have x minus 1 times x minus 1, it is probably going to look like this, x minus 1 squared. If there's two of them, they're just going to write it with a square there. And so here's our answer. Over here are our excluded values. Okay, questions? Okay, here's the last one that we're going to do as an example. So I've got 2x to the third plus 4x squared over x squared plus 2x times x squared plus 3x over 6x plus 10. So, right here, I am looking at how to factor that. What can I do to factor 2x to the third plus 4x squared? That one's not going to factor into like two sets of parentheses, right? What does it have that I could pull out? 2x squared for that one. So I'm going to factor out 2x squared, and that is going to leave me x plus 2. I can factor an x out of this bottom part, so x times x plus 2, times, up here I can do x times x plus 3. In the bottom, I could factor out a 2. That gives me 3x plus 5. So sometimes you have greatest common factors instead of being able to factor into two binomials. So we need to do excluded values before we start canceling. So with this x right here, I'm going to have x cannot equal 0. This part is going to be x cannot equal -2. This 2 doesn't do anything because 2 cannot equal 0, but 2 doesn't equal 0, so you don't have to worry about it. And then the 3x plus 5, this one sometimes messes students up because they can't do that part in their head as easily, but it cannot equal 0, so you subtract 5. 3x cannot equal -5 divided by 3. So x cannot equal -5 thirds. So if you have a factor that is not just x plus something or x minus something, you just set it not equal to 0 and solve. So you got 3 excluded values over here for this. And now we can just start canceling. So this x plus 2 and x plus 2 can cancel. I can cancel this x with this x here. I can cancel this 2 with this 2 here. So I end up with the only things I have left on top are x squared and x plus 3. On the bottom, I've just got 3x plus 5. And that's how I'll leave my answer. Today, there's really not a lot of adding and subtracting, but we're going to see that on Monday. Questions?